Hello, YouTube. Just working on some basketball shot clocks for one of the local schools in the area. And it's a Nevco, and this particular model is a SCD-5. And I took it all apart last night and was just trying to see if there was any electrical components that looked fried or anything obvious, like a wire that had got corroded off or whatever, but couldn't find anything. So this morning, where is it? Yeah, right there. In Canada, there's a number 1-800-461-8550. I phoned that number and it did put me through to in the States. And I talked to a really knowledgeable fella there. And he said, if you plug this score clock in to 110 or whatever, 120 volt, it will not light up. It has got to have this coaxial cable plugged in, and it gets signal from the main controller. So we had some other score clocks. If you just plugged them into the wall, they would fire up. And then if you didn't do anything with the clock for however long, it would go into sleep mode. So I thought this clock was going to be the same, but when I talked to that fella, he said no. So of course I checked all the obvious fuse ports and stuff. Nothing was apparent there. And then I did take the back off. These just plug in, and I just numbered one of them with 1, so I knew what port it went into. And then just left that separate. And then I did pull off the whole circuit board here. And this transformer appears like it's a AC to AC. And so it goes from 120 volts AC to, it looks like, around a 25 volt AC current. And underneath this board in the back corner, there's another transformer, and it appears that it goes from AC to DC. And then it comes back up into here with the yellow, red, and blue wire, I believe. And it looks like it's putting out 9 volt DC. So I asked the guy that on the helpline, and he wasn't quite for sure, but he said that sounded about right. So then I said, well, on the board, when I took it off and I shined the light through it, it wasn't like there was any burnt circuits on the board that I could see. And he just said that normally if anything happens to these boards, it's this electrolyte capacitor. And I have had a lot of experience with burning out capacitors. And he said sometimes over time they drain out. And so then I was looking down right where that wire comes out of the capacitor, and it was like there was something that had seeped out of there. So I'm wondering if over time this capacitor just isn't shot. And it's a 4700, I think it's called microfarad. Not nanofarad, I think it's microfarad. I'm just learning about all of that. I don't understand it, but I went and looked through all of my like meters that I had. I've got a Fluke, a Greenlee, and a couple of these just straight up Mastercraft ones. And this particular one actually has a capacitor. It's the only meter I have that has a capacitor one. Now I think this side is the negative. If you watch YouTube videos on capacitors, usually they have a strip on them. But because this one isn't hooked up right, it has an in and an out, and I think the positive is on that end and the negative is on this end. I need to take this off again because I think it just gets charged in one way and then back out that way, because I don't think this side goes anywhere on the circuit board. So I hope I have that correct. And ultimately, I think if I find another capacitor that is similar to this one, I could cut the wire there, cut it here, and then just actually solder a wire on to there, and then just have my capacitor mounted somewhere else. And I think it would still work. Then I wouldn't have to solder directly to the board. So yeah, that's where I'm at. I'll keep you posted and see where we end up. So shout out from the local landfill here. Need to find that capacitor to fix this score clock. So I knew there was an electronics pile here. Found a old computer, and I'm thinking that somewhere I have got to be able to find a capacitor that's going to work. So I'm going to cut this out, and then we'll have a look, see what we can come up with. Okay, so we took this capacitor, and that's the negative side that was on there. And then we established that we believed that it was fried. And so then Jim hooked it up to his meter, which charges and discharges the capacitor, right? Okay, and basically if you plug it in here, it doesn't charge, which means there's nothing home and that the electrolyte has leaked out of it or something. And then if I put it on my capacitor meter to try and read the microfarad, it doesn't do anything. It'll show nanofarads, but not micros. So this is wrecked. Then we went up to the Worsley dump, took a whole bunch of electronic parts across there, and then we have smaller ones. This is like a 2200 microfarad. And we hook it up to the meter, and we get 2260. So it's right there. Oh, yes. And then 16 volt. So this one here is 16 volt. And the one...
4200 microfarads.
Right.
Right.
Right. Well, 47 on this one.
47. Pardon me.
Yeah. So if we get another 16 volt, and then the only question we're stuck with is if we can parallel more than one, right? That's what we're hoping is
parallel them.
Yes. If we could parallel a bunch of these together to equal the 4700 of the one that's there, then maybe we can get this board to work. So that's where we're at now. We found the problem with the board, and then now it's just a matter of either finding the right capacitors to link together, or if we got lucky and found the right size of one, but that's looking harder than... Okay, perfect. Okay, what a long day. Oh my goodness. Had some life stuff come up along the way, and then by the time I went to the landfill and got a whole bunch of capacitors, found some capacitors that I think will work, and then I went to my good friend neighbor's place, Jim, and just confirmed a few things with him because he has a different meter than I have. I think that I was on the right track, and he confirmed that. So now basically if we want to try and rebuild this clock, this was the capacitor that was in it. So we marked what side was negative on the board, and then we nipped this off. We did double check it, and it is wrecked. I'm hoping that that's the only component that is wrecked on here, but when a capacitor goes, it could have took out like a microcontroller or something like that. But we're hoping that because this is screwed, hopefully it's the only thing that is. Okay, now it is 47, so 16 volt and 4700 microfarads, I believe, right? Okay, and now what we have here is I can't find one like that. And then we have some of these that are 16 volt, 2200 microfarads, 16 volt, 2200. So now, and look at the size doesn't matter on this. They're completely different sizes, and they're the same microfarad rating, right? So that's 4400 there, and we need 47. So we're 300 off. And then this one is a 1000, 16 volt. So basically, if I hooked these in series, as far as I can read, it says that you would have the capacitance of the least amount of the capacitor in the series, which would be 1000. So that's all you would get for capacitance. But if you hook them up in parallel, then you get the sum of all three. So then you get to add them together. So I'm going to solder these together in parallel off camera. And then I'm going to check it with my meter, and I'll know right away if I'm up to 5,000, 5,500, some number over what this bad one is. And then all I'll have to do is run a wire off of the negative and solder it here into my positive. And then we're really hoping this board will work. But it's still a long shot because something else could be wrecked on here, but keep you posted. Okay, now this is just two of them. So this is the two 2200, so 44. And then it's a pretty crude job here soldering together. I just stripped some wires, so I'll put paint on electrical tape over that to keep them insulated. And then we'll see if I can zoom in on the meter there. And then I'll hook. So this side is the negative side. So I'll hook it up, and then if you keep an eye on the meter, it's moving over to MF, not NF. So now this is in thousands. So 4.7 is 4,700 microfarads. So just with these two together on here, I am at my 4,700 capacitance that the old one was. So now as long as I can get these two ends soldered on there and separated, hopefully I gave myself enough wire that this should work. Let's hope it works. Okay, I got it soldered on. Negative, what a pain in the butt that was. I'm not really set up for soldering to circuit boards. Good thing it had the stubs sticking up. So anyhow, we'll plug it in tomorrow and we will see if it works, and if not, it'll all have been for nothing and I can just send it out for repair. Welcome to the Minnow Simons School. There's the shot clock, that Nevco. There was the working clock, and then they took out that other clock. So I hooked it up. So excited today, right? It's all working. That's the replacement. I double stacked them two capacitors and soldered them in like you've seen on the video. And we had to have the clock to test it. Again, that customer support guy down in the States was so helpful. And we plugged everything in, function tested it, and away she works. So rockin' awesome.